Hello everyone, welcome back to another IB Chemistry Standard Higher Level video, 2025 SPEC, Structure 1.2, the nuclear atom, specifically 1.2.1, which is the SPEC point. Atoms contain a positively charged dense nucleus composed of protons and neutrons, and negatively charged electrons occupy the space outside the nucleus. So, presumably, we've all seen something. Okay, 1, 2, 3, 4. That looks a little like this for an atomic sort of structure. Now here, these different dots, they represent different things. And we're going to get into that right now. So here are pink dots. Let's just say that these are the protons. And our purple ones, we'll say that they are neutrons. So the yellows will be our electrons. Could also be written as E minus. So, what are these subatomic particles? So, a proton has a mass of 1 and a relative charge of 1 as well. Neutrons, they also have a mass of 1, but as they're neutrons, they're neutral charge of 0. Electrons, they have a negligible mass, so we say that it's 0 because it's just such a small number. And as you can see by this negative over here, this will have a charge of -1. Now, neutrons and protons, these are only found in the nucleus of an atom, this right here. And neutrons and protons conjoined can be referred to as nucleons, the subatomic particles in a nucleus. Now, if we were to look at the periodic table example, or if you're given an element, you might be given, say, Na1123. So, the nuclear symbol for sodium. And here, the number 23, this represents our atomic mass. Atomic mass. An atomic mass tells us how many nucleons there are in the nucleus. And A here, it's just the chemical symbol of the element sodium. And 11, this is our atomic number. So this also tells us that the sodium is the 11th element in the periodic table. Now, what we need to know about nuclear symbol and how to work this notation is that your larger number is always going to be the mass. Your mass number will always be larger than your atomic number. So that's one way to differentiate the two if you're having a hard time. Now, as we know that 23 is the atomic mass, if someone were to ask you, how many neutrons does this sodium have? You would take your atomic mass of 23 and subtract your atomic number of 11, because your atomic number is how many protons are present in the nucleus, and this will give you 12, which is the number of neutrons in the nucleus. And that is really all for this topic. This is a very short subtopic. So thank you for watching, and I hope this helped.